After we have gotten the SS total, SS treatment, and SS block, the next thing is to evaluate what SS error is all about. The sum of square error. The sum of square error is equal to sum of square total minus the sum of square treatment and sum of square block. So we have SS error as equal to sum of square total is 0.7515 minus sum of square treatment 0.2803 plus 0.0973. So we add them together, bringing it out, giving us sum of square error. After the whole thing, then we set the hypothesis for both treatment and block. So we have it H0 is equal to the mean. Are you getting me? You know, when we are using ANOVAs, we are testing for more than one populations, maybe 2, 1, 2, 3, 4. Me 1 not equal to me 2, equal to me 3, equal to me 4. And alternative hypothesis of this is telling us that mu I not equal to mu j. What this implies is that mu 1 may be equal to mu 2, may be equal to mu 3, but may not be equal to mu 4. And all of them can be different. So we always write that at least one of the treatment mean is different. Then the same thing is applicable to the block as well. Then we come to our ANOVA table. We know that in ANOVA table, the first things to write is the source of variation, which we have said XV, source of variations. And this source of variation we have here, degree of freedom, sum of square, mean sum of square, F calculated. Here, we have treatment, we have block, we have error, we have total. The degree of freedom for treatment, you know, treatment is 4, and that is K minus 1, that is 4 minus 1, giving us degree of freedom for treatment to be 3. Then here for block is also 4. Degree of freedom for block is also 3. Then degree of freedom for total is NK minus 1. That is 4 times 4 minus 1. That's 16 minus 1, giving us 15. Then for error can be done by subtracting the sum of the degree of freedom of treatment and block from the what? From degree of freedom for total. So this is 6 minus what? 15, giving us 9. Then the sum of square for treatment is 0.28. We have gotten it before. The sum of square for block is what? 0.0973. Then the sum of square for error is 0.3739. Then here we have the sum of square for total, 0.7515. Then after we have done that, you use the degree of freedom, the sum of square of total for treatment divided by his degree of freedom. And that gives us what? 0.0934. The same thing applicable to it in this way. 0.0973 divided by 3, giving us the 0.3739 divided by this, giving us this.